So, okay, there's a little background on who I am. You can all check it out on LinkedIn if you like. Basically, it's a long, strange trip from government and Russian studies to data science and process mining. But it does enable me to answer one question, maybe two. Number one, did the Russians interfere with our last election? Yeah, of course. They've done it since 1920. Why would this be any different? And we do it to them. And secondly, did it matter? No. Right? It had no effect. Now, by the way, has anybody here ever met Hillary Clinton? Ever had the opportunity? You met her? You've seen her? Okay, I had the opportunity one time to actually meet Hillary Clinton. And I was senator, and I was in the receiving line. And Mrs. Clinton's coming down the line. And you know how those go, it's a lot of, politely insincere handshakes and comments, right? And she comes up to me, and I said, Mrs. Clinton, I said, I heard you speak last night on Elian Gonzalez on a debate, which I think was at SUNY Buffalo in New York State. And I said, I absolutely agree with your position. And now, she's coming down the line, and she stops. When I say that, and she looks at me and goes, oh yeah. And all of a sudden, now she drops out of receiving line mode, and she wants to have a conversation. And now, one-on-one, we're having this really interesting chat about the issue here and the implications. So much so, they're going, listen, I'm sorry, I have to go. And now she was back into putting in sincere mode. And what I realized is, this is a woman who is outrageously in command of facts and issues, and my gosh, I mean, here is somebody who is phenomenal. But at the same time, that's not how you get to be president. You get to be president by emotionally feeling somebody's pain. As Steve talked about yesterday, how to make decisions, right? Bill maybe understood that too well, right? But Hillary, my gosh, had she been in the Senate, she would have been the lioness of the Senate today. I don't think anybody better than she. Anyway, that's just a little sidebar. But no, it's been a very interesting time. I was on my way to being, a policy analyst for the government when I learned pretty quickly that I hated it. Right? Not only that, but what I was doing didn't work. And what I learned that was by reading a paper by an MIT professor named Jay Forrester, who was the founder of Systems Analytics. And what he said, the paper's called The Counterintuitive Effects of Social Behavior in Social Systems. And what he said in the paper, it proved mathematically, is that you feel badly because there's lots of poor people and lots of homeless people. You build a housing project, you feel better, and what do you get? More homeless people. You get more homeless people. I said, my God, he's right. We're making the problem worse. Then I went to stand it upstream, back to engineering I went, and wound up actually working on an idea about how you could discover and rebuild processes from the data. So we always look at processes, we take a process, and we try to say, okay, what does that mean? Well, I figured out, let's reverse engineer it. Once it's already in data, how can I reverse engineer it and actually recreate the process reality from the data itself? And that's a fun time. Now, let's talk about intelligent automation. What is it? Well, if you go out and look for definitions, I find it really interesting. Almost every definition is structured around what somebody wants to sell you. Anybody shocked? Now, the RPA vendors will say, hey, it's RPA on steroids. That's what we're doing here. Right? AI guys will tell you, oh, this is really, artificial intelligence. That's what intelligent automation is. And so the BPM guys who are still alive will say, this is really all just the next step in business process management. Yeah, okay. But let's try to come to something here, right? Intelligent automation, right, there's really two words. Intelligent and automation. Now, I have to go back to the basics. And really, we're trying to mimic activities that are carried out by humans, and then learn to do them even better. That's the idea. And rule-based automation, basic RPA, augmented by decision-making capability, but focused on processes. Now, when we get to the intelligent part, Really, we're talking about data and algorithms to augment human judgment. So, can you augment robots with intelligence? Anybody think yes or no? How many say yes? No. Tastes great. All right. Okay. Okay. So here's the way we got to think about work. Whoops, sorry about that. Okay. Right. There's only two things you can do with work. Now maybe you've all seen this on a recent Accenture advertisement: to automate or to augment. Right? That's the question. However, this whole idea that augment or automate work was developed in 1962 by a fellow named Doug Engelbart. Doug Engelbart was the fellow who invented the mouse that you all use when he worked at Xerox PARC. But before that, he worked for the Stanford Research Institute and did this research for the U.S. Air Force Strategic Command, where they said, hey, Doug, we got these new things called computers. What are we going to do with these when it comes to all this office work and all the stuff we have to do? And he said, well, there's only two things you can do. We can either automate the labor that the human's doing, or we can augment the human to make better decisions. End of story. And so far, no one's figured out a third thing that you can do with these. Now, I guess that's not quite true. With AI, you can actually start to create as well. And that moves off in the Z space, right? But for the most part, those are the two things you can do. And if you do that properly, and you take it to its extreme, what you get is something I call the zero point, which is we've now optimized the energy of both human and digital labor to the point that it's all focused on one objective for each task, and that's a simple over the top. But now, let's think about how we take this forward with work. The way I think of it is, there's really two basic things. There's transaction volumes and human touch. Basically, interactions and transactions. And based upon that, you can take almost any task that's done in a process and array it to the matrix. Hey, every professor has to have a 2x2, am I right? If I don't have one of these, then I can take my unique card back. But the issue is, right, let's take a look at with high transaction, low interaction tasks, right? Claims processing, invoice processing, people are really looking at taking data, looking at them, is the data correct? We're doing data validation work here, right, to make sure we can go to the next step. Things that are high transaction, high interaction. Those people that are customer service agents, right? They're on the phone. Let's go. Next. How am I doing? What am I doing there? Let's go over to the left. Let's talk about high interaction, low transaction work. You go to see your physician. You go to see an accountant. I'm dealing with people that are, one at a time. I'm having basically not a lot of transactions, but when I do, there are a lot of highly interactive efforts. And lastly, low transaction, low interaction efforts. These are things like maintenance, things of that nature, where we're focused on both not a lot of interaction, and I can't do many of them a day or a period of time. So here, I'm going to borrow some concepts from Engelbart, and I'm going to apply them to that framework. And when I do that, what I see is, when I'm in the high transaction, low interaction, here we're really talking about process automation type activities. I have human decision making, and I'm going to do as Engelbart said, I'm going to automate that. When I'm looking at, I've got high transaction and high interaction, here I'm going to use the technology to make the human better at what they do. I'm going to go out, I'm going to get the data, I'm going to do everything I can, like using a chatbot, to help them really understand what's going on better. When I'm on the upper right, on the upper left rather, I'm thinking about advisory services. Now I'm augmenting somebody to make a decision better. So if I'm let's say I'm a radiation oncologist, and I'm focused on understanding what exactly the nature of the disease might be. I'm using predictive analytics, image processing of MRIs, all to figure out where the false positives might be. And now I'm coming up with an array of possible clinical pathways I might suggest to the patient that they may want to go on their treatment journey. Now, all this has done is make me, take my intuition, what I learned in med school, and now it's made me a lot brighter by helping me understand the options, and I'm not going to make, because if they find options, of course it will, but I might not have considered what pathways are out there, what the success rates have been, and now I can bring that to the table and have a great discussion with the patient on the future. Now, the last section I call autonomous allocation. Here's what I mean. This is where Steve showed the picture of robo-bosses, right? Here we go. This is a case at Stanford, right? Spent a little bit of time. And what they've done is they've started implanting sensors all around campus in their building and ground. So they're taking soil weeds, everything else but air, humidity, and they know the profile of the vegetation that's planted in that area. And they take all that, they fly drones over the sensors, pick up the data, transmit it, back to their data center, runs through, what amounts to be their AI system, which has the profile, matches the profile against what the current temperature states are. That information is then used to schedule the crews to go out to do maintenance, and based on that, when to roll a truck. So the robots are actually now, the automation is actually directing the people in their efforts every day. What's the result? They've been able to lower their carbon footprint by 35%, as well as their cost by 40% so far. So it sounds like we got an Amber Alert. Yeah. That's okay, sorry about that. Now, what we can do, every process in your organization is composed of tasks. And all those tasks, all those processes and sub-processes can be broken down into individual tasks. I didn't render right there. That's okay. It didn't quite render right, I can see. But what happens is you can now take each of these process tasks and array them into the framework. And when you do that now, you understand, okay, I have a lot of pieces on the lower right, that's process automation. I have things over here that are really more interaction oriented, and those that are more think of them as advisory oriented. But the key is, we've actually taken a look now, and this whole process is mapped onto the quadrant, each with its specific place. What that tells us is, now, what we can start to do to understand what's the first thing we need to know. No, not the kind of data, that's next. But how am I measuring this? This is a process. How do I know if I'm efficient or not? What is my objective for this? For each of these, we look at a number. What's the desired outcome and what's the number? And based upon that now, we can take the next step and start to look at what I call process as primitives. Any of my Amsterdam friends still there? Yeah. Process primitives, right? What we talked about here from Dijkstra, one of them used to say every program can be broken down into primitives of sequence, iteration, and selection. By the way, I have two famous programming language types from the University of Amsterdam, Dijkstra, and the person that invented Python. You know why you call it Python? You do? Monty Python. Why? Because programming is such a disaster. Right? And he said it reminded him of Monty Python's dance. By the way, most of business is like you can call Python. But these are the four primitives that I see. Data, type of data, decision. What kind of decision is going on here? Is it deterministic, if then else, or is it something judgment-oriented and probabilistic that we're going to use? Based on that, what action are we going to take? And then what outcome are we looking for? Each task has those four primitives. And you need to figure that out to be able to understand how you're going to design something that solves the problem. Now, here's the next part of it. Since we're talking about intelligent automation, I say there's four levels, starting with 0, which our European friends will like. 0, RPA. Why? Because it's simply rule-based approach. There's no learning here. right? If this, then that. All I gotta do is put it in place and off it goes. Level 1, enhanced RPA, right? The learning is applied to the bot. Now, why would you do that? Well, we'll go through some examples, but when you're processing some data, you always wind up with suspense or some kind of pending file that isn't finished. It needs to human work. What's a major cause? Often, data quality issues. How do you fix that? Computer vision OCR. What is that doing? It's automating the work of the bot. It's enhancing the bot's productivity, not the human. Now, those of you who spend any time in manufacturing, this is a typical problem, right? Machining, once you put down a manufacturing line, boom, now we're going to increase the productivity. All we're going to do is look to replace what machine is better than another. All we're doing is here is making the machine a little better. Now, level 2, cognitive augmentation. Now I'm actually thinking about what kind of learning do I need to make the human better in their task. And number 4, I'm actually doing some predictive analytics. I'm going beyond simple cognitive automation. I'm actually starting to drive something that's actually adding predictive value using AI in that organization. So, one more Engelbart enhancement. Now I'm going to think about all the technologies I might be able to use against that task and that data to be able to supply some level of learning to that, to be able to increase the productivity. So now what you've built here is an intelligent automation or learning profile of each task that you have. Yeah, and we can do the math on this. It's a great optimization problem. That's what you learn. Now, I thought this is a very useful comment from McKinsey. They said RPA is taking the robot out of a person. Think about that, right? Now, I'll give you a story. Right, this first, a young engineer was working after I got out of the steel industry, working in the healthcare. And first young guy, first day on the job, I'm called down to HR. I go down to HR. It's about 4 o'clock in the afternoon. And when I get off the elevator, all of a sudden I see this herd of women that are running and they were running for the door. I think, my God, it's fire. And so I turn around and I start running out the door. And I get out the door and I realize, oh my God, they're running to their cars. So I walk into HR and say, hey, just met the happy employees, right? These people couldn't wait to get out. Why? Well, we're going to talk more about this. But they were doing, basically Medicare claims coding. How many hours a day of that? They were probably pretty just a scream. Now, of course, there were also issues why they had to go home, obviously, for a lot of child care and things like that. But this technique of people, this is the worst work you can do. And frankly, to read a good discussion of this, I recommend this book by Ron Paulson. Ron Paulson, he's a Swede, and it's Cambridge Press. It's Empty Labor. He goes through a lot of discussion about just what you get when you've got the robot in the person. It's a wonderful read. Very dry, but in that blunt humor too. Now, why are we even doing this? Like I said, for fun and profit, right? Well, let's talk about profit first. How much empty labor do you think exists? And not empty labor, but robot type labor exists in these processes. I'll go through a couple for you. This is one I showed in my workshop, and I'll go through a couple points. But basically, looking at invoice processing, the case I just showed you, the first step in that was just taking out the basic deterministic moves, saved them about 1.4 million. The next step, taking it to using OCR, actually took out another $300,000. Right? That's just on step 1. Step 1 and 2. 1 and 2. So they say in this about 47% decrease in cost in that one piece. Now let's go to the second example, because I know we have a whole lot of time. let's talk about the same kind of process. Here we're doing insurance claims for a large health insurance company. All of this regarding, all the thousands of reasons something could reject, all the claims they process, how complex they are, all the reasons for this. Right? We discovered this, we laid it all out, and you know what that added up to? $37 million a year. Right? Now, this company actually saved what amounted to be $17 million at level 1 a year. And an additional $12 million when they brought in the OCR and automation computer vision equipment. Right. So that's a whole lot of money. 29 million from 36 per year. They're able to take out of that process. By the way, that drops right to the bottom. Third, but you can't do this though in some cognitive activities, right? How would you do this if you had something in the upper left? Well, we took a shot. This is a project we did for toxicology lab. Right? You ever wonder what happens to your blood or urine sample when it goes to the lab? You ever get a reading back that's really, really wrong? Right? Well, a friend of mine just got one. They said his triglycerides were 1,000. I said, huh? What are you talking about? Well, the answer is, it was a false readout of the machine. And every one of these things is reviewed by a toxicologist. Why didn't they catch it? Well, because after 3.5 hours before work, the error rate on a toxicology read goes up to almost 60%. Yeah, right. Right, yeah, little help back. So when you go through this, same game, right? Do it the same way, and what you see is they saved about $1.5 million. Now, this was different because they're focused on quality. So we did a lot of data science behind this, pulling data off the machine to be able to really give only the toxicologists what really needed their review that we couldn't do with some basic confusion matrices and other basic data science. So now that you've taken all the robot stuff out, the fun begins, right? Well, the person that I like to read about this is Professor Teresa Wellborn from USC. She studies what she calls corporate death. Meaning, everybody goes public, why do some people succeed, why do some die? And if you want to know the answer, there it is. I have nothing more to say. Right? But, of course, but if you send me a note, I'll send you the references. But you can also find them on Google Scholar. But what she says is that really employees need to understand the inner workings of their organization, and she has a model for this, and how to engage in behaviors that support the company, not just the jobs. So what they need to do is to feel engaged in the organization. And not just engaged in terms of, gee, I like what I'm doing, and I like this, but more to the point, I have a sense of ownership in what I do, and I'm actually helping to build this idea and drive it forward. Now, I'm doing some work currently for a very large equity company that just spent $1.1 billion to buy let's call it a healthcare revenue cycle management company. And they have a very sophisticated set of processes, not so much automation. I think there's at least somewhere between 30 and 50 million a year of, intelligent automation opportunity in the RPA level 0 and 1 alone. And they said, great, let's get started. I said, stop. No, because I listened to them and I listened to how they implemented this outrageously sophisticated system of people and manual and what they do. And they have what amounts to be, those of you who remember Toyota quality circles, where the employees work together to come up with ideas, and then they figure out what the improvement should be, and they have teams. I said, guys, these are very engaged employees. if you think you're just gonna go shove automation in there, right, you're gonna start watching a lot of those returns you promised your investors. Goodbye, they're not gonna be there. For just the reasons she talks about, right? They are engaged, they understand what they do, they communicate, they try to improve things, they're engaged employees. Now, she also says that if you're really focused on getting your employees on those core things alone, like this equity firm is focused on, that's all they do, is process claims, not you, right? Then it's easy, right, for someone else to simply replicate this and hire the employees or outsource the work. Not a problem. You can automate it all day long, but guess what? Those robots aren't engaged. They aren't making it better. If you have learning, you might, but no, those aren't engaged. Then stop. You're gonna break the culture. So when we implement intelligent automation, we need to be intelligent about how we're approaching the problem. Engaged employees and people that have a sense of ownership in improving what they do. Right? My father, back when I was growing up, my father was an engineer for Bethlehem Steel. And he was also an expert in building what amount to be highly refined, engaged, highly refined products for the U.S. Navy, let's put it that way, right? Widgets. He was a milling machine expert. They decided to automate this so they could bring in paper tape machines and then they could de-skill the workers. Guess what? Productivity went down. What they found was the only way productivity went up was when they took their best and engaged workers and put them with the automation, and then they broke it through the roof. Very famous study has been changed on this. And that's the same point here. We have to be smart enough to know how we're going to import this. Now, lastly, I'll leave you with something I've been saying for 10 years. Dr. Ed's foundational principles here. Number one, every software robot are going to do to computing, and how people do to services, what they did to what industrial robots did to manufacturing. How much did manufacturing productivity increase in the last, let's say, 20 years? What do you guess? Over 100%. How much has services, which is now 84% of the economy, increased in the same time period? 20%. RPA, right? Intelligent automation is going to do the same thing to that level of work. And as corollary, all work that can be done by software robots and cognitive computing will be. Take that to the bank. All this story of, oh, we're going to work together and have this straightened out. Everything that can be will be, and the key is going to be, you need to have, and that becomes ubiquitous, an engaged workforce to survive. Question? Yes.
I actually hate the customer service robots that you can't even go to your credit card company.
Yeah.
The last time I actually phoned my credit card company, I usually just say operator until it goes to the real person. But this time, it was so well executed, program, that I just went with it, and they were able to answer my question, and I just got on the phone and never talked to a real person. That was the first time I actually ever did that. So you see that.
So again, we're learning is going to get better as we go along. But we can expect it to improve. But again, that's how we work. Thank you. You've been great.
Thank you, Walter.